We made a difference. We made it together. We made it. Power systems engineers work with teams of people who have many different areas of expertise to design and deliver power systems in cities and rural areas. These might include engineers working in energy, electricity, civil, mechanical, or structural, as well as architects, city planners, and other consultants. Incredible grid systems power the lights in our homes, our iPhone chargers, our refrigerators, our schools and hospitals, and most everything in our daily lives. A blackout usually hits with extreme heat because the system gets overloaded, or with extreme cold, such as ice storms, which means engineers have to work as quickly as possible to restore power to keep people safe in the intense weather. They also have to prioritize power restoration between different locations, such as hospitals, airports, schools, nuclear power plants, malls, or residential neighborhoods. In 2003, one of the largest blackouts on record hit the northeastern seaboard. 55 million people were affected. For some, it meant barbecues outside and no school. But for many people, it had devastating impacts on their lives. Spoiled food, no air conditioning in hot summer heat, missed days at work, and even death. Hospitals had to run on emergency generators. In some areas, the power was not restored in a matter of hours, but for most places, it took days. The challenge. In this lesson, you and your team will become power systems engineers. It is your team's job to troubleshoot a malfunctioning circuit board and to rebuild it based on where to restore power first. Each member of your team will have a different role in getting the community back up and running. The first role is Power Systems Engineer. Power Systems Engineers assess the situation in order to identify the problem and determine the best outcome of action to solve the problem safely. The second role is Project Manager. Project managers overlook the work of the engineers and designers to ensure that their recommendations and solutions are accurate and are the most effective way of solving the problem. The third role is Designer or City Planner. Planners know the workings of the community the best, so they determine which areas hold a higher priority and require power first. Materials. You will require a breadboard wire links, 3 LED lights of different colors, a 9-volt battery, a battery clip, an 820 ohm resistor, and a 330 ohm resistor. Consider how series and parallel circuits function in order to build the circuit in this schematic. When you are complete, you must problem solve to determine how to make all 3 LEDs light up and return power to your whole city. Be prepared to communicate your circuit solutions to the team. Good luck!